Good evening everyone. Welcome to the YouTube channel Just Information. I hope you all are fine. Today we will learn class 7th science chapter sound part 4. In this part we will learn about uses of ultrasonic vibrations by animals. First, dogs can hear up to the frequency of 40,000 hertz as compared to humans who can hear up to 20,000 hertz. Dogs can be specially trained to respond to a whistle which provides ultrasonic vibrations. This whistle is commonly called Galton whistle. Galton whistle. The sound of this whistle cannot be heard by humans. Bats can produce vibrations in the frequency range of 50 Hz to 80,000 Hz. Bats have very weak eyes. When bats fly at night, they produce ultrasonic vibrations which cannot be heard by humans or the insects. When these vibrations strike the insects, they are reflected back. On receiving the reflected sound, the bat can locate the insect and eat it. Third, dolphins are related to whale family. They use ultrasonic sound to locate their prey much the same way as the bats. Now, measure of loudness of sound. Measure of loudness of sound. So, the loudness of sound is measured by decibels, dB. Decibels, dB. And it signifies the sound pressure level. Human ears can pick up sound from 10 dB to 180 dB. Human ears is equal to 10 dB to 180 dB. A normal human being can tolerate loudness of 80 dB. The sound above 80 dB is painful and causes various health problems. The decibel scale. 10 dB is equal to 10 dB. Quietest sounds our ears detect, such as a ticking watch. Now 20 dB and average whisper. 40 dB quiet talking with people nearby. 50 dB television or radio that at an average listening volume. First 10 dB, 20 dB, 40 dB, 50 dB. The next is 60 dB, fairly loud conversation. 70 dB is appliance such as vacuum cleaner or food processor. 60 dB and 70 dB. Next one is 80 dB, train passing through station. 100 dB, very loud machine or tool like road drill. And last is 120 dB, like a jet plane at takeoff. 80 dB, and 80 dB, 100 dB and 120 dB. The question is, why do the sounds differ? We hear a variety of sounds produced by different vibrating objects. Examples are: first, difference between the sound of sitar and that of a violin. Second, the sound of crow is different from the sound of cuckoo. Third, the sound of different boys in class is different. Fourth, the sound of a girl is generally shrill compared to the sound of boy. Now, what makes these sounds different? Answer is the different objects produce the different sound because either they have different loudness or different pitch or both. Loudness or intensity of sound. Loudness is the characteristic of a sound which distinguishes a feeble sound from a loud sound of the same frequency. The loudness of sound depends upon three factors. First one is the amplitude of the vibrating body. The amplitude of the vibrating body. Second is the area of the vibrating body. The area of the vibrating body. And third is distance from the source of sound. Distance from the source of sound. Now, first, the amplitude of the vibrating body. So, here is the diagram less amplitude and louder amplitude. First is more amplitude means louder amplitude. First amplitude, okay. In this more amplitude, less amplitude. In more amplitude, the figure is like this. This is the amplitude, more amplitude, louder amplitude, louder sound. And in next, the less amplitude. Amplitude less means feeble sound. Now, second, the area of the vibrating body. The more the area of the vibrating body, the more is the loudness. For example, a large drum will produce louder sound than a smaller drum when struck with some force. Next, it the skin of large drum sets more volume into vibrations and hence produce louder sound than the smaller drum. Now the third one. Distance from the source of sound. Loudness decreases when the increase in distance from the source of sound. When you are close to the loudspeaker, you hear a louder sound as compared to some distance away. It is for the same reason that you move to from front desks when you cannot hear your teacher at the back benches. Now, pinch. A voice of a woman is more shrill than the voice of a man. The sound produced by a flute is more shrill than the sound produced by a tabla or a drum. A shrill is called a high-pitched sound, whereas a soft or less shrill sound is called low-pitched sound. What is this pitch? Pitch is the effect produced in ear due to the sound of some particular frequency. Pitch is the effect produced by the ear due to the sound of some particular frequency. The sound of some particular frequency. Now, the higher pitch depends upon the frequency of a vibrating body. That the higher the pitch, the more is the frequency, and the lower is the pitch, the less is the frequency. Now, some examples. Musical instruments like jal, tarang and flute are based on the vibrations of air columns of different lengths. Second, the siren also works on the same principle. However, when initially the siren is started, it produces a sound of low pitch. However, as the speed of its rotating discs increases, it produces a sound of high pitch. A mosquito produces a sound of high pitch. Third, a mosquito produces a sound of high pitch as it vibrates its wings very rapidly. Now we will learn applications of reflection of sound. Whispering gallery. The whispering gallery of the dome of St. Paul's Cathedral in London is an interesting example of reflection of sound. The gallery runs around the base in the inside of the dome in a circular form. There is a speciality with its gallery. If you whisper at some point, say A, close to gallery, the sound is distinctly audible all round near the wall. However, at a short distance towards the center, such as a point A, the sound is hardly audible. Stethoscope. Stethoscope. Now, the stethoscope used by doctors used by doctors works on the principle of multiple reflection of sound. Multiple reflection of sound. In a stethoscope, there are four important parts. A. Ear points. B. The collecting funnel. C. The main tube. D. The bifurcated tubes attached to the main tube. Now functioning. The doctor places the ear points to its ears, pressing the collecting funnel against the chest of the patient. We will draw a diagram of it. First, ear points. Two lines. These lines are called two bifurcated tubes. And we will color this part with black. These are two bifurcated tubes. These are ear point. Ear point. This is the main tube. Again with black color. This is the main tube. And this is the point where the doctor checks with the help of this. This is collecting funnel. Collecting funnel. Now, thank you for watching today's video. I hope you have understand this. For any queries and doubts, please join the Telegram link given in the description of this video. Thank you for watching today's video.